Thank you, Konstantin. Thank you. Good afternoon, distinguished colleagues. We represent the SPb-Giproshakht company. My name is Andrey Koryakovtsev, and my colleague here is Elena Dyukova. We will tell you today about designing infrastructure facilities on the gold extraction factory, and we will tell you about the project and its progress and how it was implemented. Giproshakht since 2005 has been part of the Severstal public joint stock company. Our key customers are mining enterprises, for example, internal customers such as Severstal, and external customers like Evraz, Metchel, and others. Since 2015, we've been working on in a new business, for producing a new business products for metal frames, and we are currently working with big companies, with major companies, working via EPC, EPCM contractors like Willistroy, Timmermont, and others. We added this slide to show you that today, for BIM and the industrial application, there are two possible ways, two possible scenarios. Some of the companies provide information modeling using a single platform. They base all their business processes on this platform, on a particular platform, while others do not have the chance, do not have the possibility to use the unified, the only solution, because they'll lack certain functionalities tailored to their tasks. So that's why they need to use various software solutions. So we are supporting the concept of open BIM. So for various parts we use various software solutions for frames, for nodes, and for the assembling of the information model. In this slide you see what kind of software solutions we are using, and further we will tell you how we ensure connection with among various software solutions. What kind of BIM uses were necessary for the project? First of all, it is the working documentation and design documentation. We also needed to optimize the level of installation and construction works, as well as check the model for collisions, and compare plan with actual status and progress of construction. We use, at the concept stage, we use the 360 Improvise product. Using the functionality of this software solution, we calculate various platforms, calculate excavating works, and this helped us understand the areas for optimization for our excavation activities. Designing roads and access. In this project we started designing roads inside the model using the InfraWorks software solution. We planned roads and profiles to develop design documentation. Using such a software solution, it is much easier and much quicker to optimize the volume of excavation activities. In this slide, I'd like to show you that we have a plan for the designed road. Our customers sent a snapshot in CL3D. We compared this snapshot with our project and with the planned road we wanted to develop. So by doing that, we regulated the volumes of excavating activities. So you see the planned and actual design in this part of the slide. We also wanted to optimize the volumes of excavation activities considering the geology data. In this project we used the terrace design method, and very often the excavation volumes reached 12 meters. So we wanted to look into geology and to understand the type of soil and to understand the volume of our costs. Before, when we didn't use the information geology model, we considered and we estimated these costs using just 2 cuts. For this project, we used the geotechnical model to create a digital geology model. I'd like to tell you right away that it was not an easy process. We needed to do a lot of manual interventions to understand lenses and the structure of the soil. We added the model to the InterWorks and calculated the volume of excavation. So we understood that for standard design, half of the soils that we considered were not actually taken into account, and the digital geology model helped us to consider all the soil types and understand what kind of what volume of soil can be excavated and what will be the cost. Because with this we understood the necessity of using explosion works for this site, explosive excavation. So this model helped us raise the precision of our estimations and save several dozens of millions of rubles. And I'd like to give the floor to my colleague. She will tell you how we developed the design model and what kind of software solutions we used for doing this. Designing this surface part, we used several products such as Autodesk, Revit, Inventor, and we used Navisworks for checks. All these software solutions are provided by various vendors, and they have they operate various file formats. We also used NanoCAD and Model Studio CS for further processing. We are using Autodesk Revit for issuing models and also use Revit servers. In each project, we organize the structure of folders, having the lead folder and subdividing it to folders for each particular site. We have dedicated folders for particular sections for this project. So the name of the folder contains the data on helping identify the section. Tagline structures and MagicCAD software solutions are used to ensure data sharing. We get IFC from Tagline structures and MagicCAD and then integrate them further to an adjacent solution. We provide connection among different blocks and elements. For all Revit files, we have basic point coordinates and the angles, so that we can assemble the model using the master plan. Throughout the design process, we do preliminary checks of collisions and also the uploading of materials, and we organize the interdisciplinary model and save them at NDF and NBD format. We do the collision check using matrices. Then we send these results to designers. This data contains information on collisions, helping engineers remove them. And then afterwards, when the collisions are removed, we finalize documentation. We also can connect the schedule, the network schedule, to the process. We prepare a list of sites that we need to integrate there: warehousing, transport equipment, and other facilities. For example, so the model is updated, and we add the schedule to the model using the Microsoft project solution. We assemble sets, data sets that are linked dedicated to particular strings. This is how we perform simulation of the construction process. Using this added model, we can understand the location of the site and locate particular buildings, including warehouses, on the site. We can understand and estimate the traffic routes and the location of related facilities. For the facilities that are already in progress, we can track the actual delay or the actual quicker performance according to the schedule. The delays are marked with yellow, while the advanced sections are marked in white areas. So the analysis helped us understand that the construction process has some delays, so not everything goes smooth on the construction site, according to this simulation. We can also integrate cash and financial parameters. We can add such parameters as equipment costs, material costs, and labor costs. And when we do this, the software can automatically calculate all these parameters, all these costs along the model. Top left corner shows these calculations, and in the middle you can see the crane working to create the facility, to build the facility. So the process goes like this, and then we see that the wall is ready. We also provide the model with drawings to our customers, so our customers can track every drawing and can understand the contents and dimensions. This only works for the AU generated parts, Autodesk generated parts. Here we don't have to. Our customers don't have to go and fetch drawings from somewhere. You can just click and see the drawing from the software. Some conclusions. So the overall and the spread of BIM is a matter of the next few years. We understand that the future depends on this technology, and research institutions will soon switch to this technology. For those of you and for those of companies who won't do this, they will need to think how to remain competitive in the design market. We were also asked to insert this slide, to use this slide in the presentation. So what are the strategic goals in 2018? So this is the sales of BIM models. explaining to our customers on why we need a BIM model, organizing automatic design process, organizing the work process inside the institution to be always on time, and also develop a methodology on the underground mining facilities, raising their detailization to LOD 300. Questions? We have some time for questions. Please raise your hand if you have a question, and we will give you our roving mic. Severstal, Metallurgy Technologies. So you showed us a list of software that included Intergraph Smart Plan, but then further in your presentation you didn't mention it. What kind of software tool you used together with Tagline? Some analog, something similar to Revit? We used only one module of Smart Plant for spooling. We used it for outlining, highlighting installation areas for installing pipes. We didn't use them for this particular project, but we used the Smart Plan product that you're mentioning in a different project. Further questions? Could you repeat your question using the mic? Do you use Tagline along with other solutions? We use Tagline to issue KM, KD, and KGM sections. This solution is more convenient for drafting working documentation, for designing metal elements and armoring frames. We can use the generated drawings for further treatment and for further processing. We have another question. My name is Tatiana Razumova, Kipro Nickel Institute. What kind of the cost of the project? Do they become more expensive if you use BIM technologies, according to your calculations? We expect 10 to 15% increase. We also have some online questions. How much human hours did you spend to implement the project? So it's a project that involved several sites. So what kind of sites is meant? For the 4D model, linking the schedule to this model, was it an overload or was it a transfer of data? I think that was the facility for the milling. I think time-wise it was 2 to 2.5 months, involving drafting documentation, working. So this was the time spent by the project team and the BIM manager. Alexei Balyshev. A question on Navis works and connecting 2D drawings. You showed us an example where you integrated 5 drawings. Did you try to connect more drawings, a set of drawings? Because we tried this and we don't have a tree structure. What we get is just a list, and I would like to know if you had anything similar, a similar practice, a similar experience. Is it convenient to do it? For this project we integrated IR, VC and other types of drawings, all the sets to the model. So you saw only 5 drawings because it was just a part of the elements, a part of the project. If you want to see the overall picture, there is also a possibility to do that. Did you like this tool? Yes, we did. It is quite convenient. If it was produced by Revit, then it is convenient. And of course, if each set has 40 sheets, then the model becomes heavy. We also have one more question, an online question, a very frequent question. What data from the BIM model can be used by the budgeting department to build budget sheets? For our budget specialists, we provided a dedicated training so that they can look into any object, into any facility, and the location of all parts, because sometimes it's not easy to understand the drawing right away. We also tried to use the to download quantities. We tried doing this. It was not always a success, and we sent the information we got to our budgeting department. Two questions. Could you introduce yourself, Ilya Budarin, PKM project? The first question on working on the cooperation of Tagline and Revit, mutual use of Tagline and Cooperate. So you use the model and you use both tools. If you use both solutions, is the model, does it remain intact? And the second question on armoring, on KGI, on other types of procedures, I think it's more easier than in Revit, because in Revit it's a very hard, it's a very difficult process. Thank you for your questions. For IFC downloads, we use it for transferring geometry objects because they are more important for adjacent sections. It is more relevant for dimensions, and they're more important for other procedures. For assembly, we also and for installation, we also use IFCs. We get such information as dimensions, brands, marks, and we use all this to draft the final documents. To your second question, all designers of concrete structures, they started using AutoCAD from scratch, and they didn't use Tagline from the beginning, so they started using AutoCAD and they're satisfied with the solution. Thank you. Let's give a round of applause. But we still have the last question. Victor, Project D. So you did electrical connections in Revit. Electrical connections section in Revit. So I saw it in your slides. Did you also reflect cabling in Revit, or you just added lamps? We put equipment. As for the rest, you used NanoCAD or AutoCAD. Yes, you're right. Well, it depends. For some parts, we used Revit, provided by our contractors. For other parts, we used NanoCAD ourselves.
Can I also have a question? That is definitely the last question. Then more new project. Question about geology. As far as I understand, you were making the geology model as well, with all ground types, right? And you calculated the volumes for each ground type. Have you done a comparative analysis of the volumes you calculated and the volumes you actually excavated? We did it in this project. We did this comparative analysis. First, we did the traditional methods of calculations, did several geological cross-sections. Then we interpolated the estimations, and after we did our geology model, we used the traditional AutoCAD methods to subtract one volume from another. We compared two surfaces and then we did this comparative result analysis on the table. But in fact, when you did in real life, but it's still going on, the construction is going on, and you haven't done it before, such comparative analysis. No, we haven't. Thank you. If you have any other questions, keep them for the discussion. Let's give the round of applause to the speakers.